So one of the things I was curious recently was if I could use the fcl-image classes with the PTC graph unit or just the graph unit in general. And after taking a look at how the fcl-image classes work, I think I found a really simple way of integrating both of them. And this little bit of code here allows you to do that. I'm just going to run it just to show that it actually works here. So I have a test image that I created in MS Paint, and let me just run it here. And it comes off screen, but like I created some simple shapes here, and they load with the proper color. But I wanted to make sure that I got everything correctly, and I think using a real photograph allows you to see instantly if the colors are being interpreted correctly. So this is what we're going to see now. And that looks great to me. And I've been able to make this work with the three modes, a 16-bit, 15-bit, and 24-bit. I don't believe there's a 32-bit mode in the graph or PTC graph, but it does work with these modes. So I'm just going to go over what I had to do to make it work in these three different modes. So the the color format is different in PTC graph for the 64K, 32K, and 16 million color displays, which is the 24-bit format. So if we look at the 16 million colors or 24-bit, everything's really simple. Uh, each color value RGB takes 1 byte, 8 bits. So it's 8 bits, 8 bits, 8 bits, and we're just shifting the bits around to basically form a long word. We do the same thing with the 64,000 colors, which is the 16-bit mode, uh, but it's a little more complicated. The format for that mode is 5 bits for red, 6 bits for green, and 5 bits for blue. Um, Now, I'm not just doing bit shifting because I think you lose some quality there. So I think this formula works better with uh, basically bringing down the 8-bit down to 5 bits and 6 bits. You can try your own way of reducing this or making it less complex, doing bit shifting, but I'm not sure how well that's going to work. I know this method works pretty good. And I did the same here, except with the 32K format, it's 5 bits, 5 bits, and 5 bits for RGB. So it's all the same here. And we do some bit shifting to, like, again, form a long word. And this is another conversion method. We're going from 16-bit color values here down to 8-bit. And this is what the fcl-image format uses. So the custom image class stores each pixel value with 16 bits of red, 16 bits of green, and 16 bits of blue information. Um, and we bring that down to 8 bits. So this is what these formulas do right here. So we're going from 16 bits color down to 8-bit color. And this function here just takes the FP image memory buffer and displays it pixel by pixel on the PTC graph. Uh, and we just go through a loop of all the pixels. So we check basically what mode we're in, and we apply the right function to convert the color values, and we basically plot each pixel. And we do the same thing for the 16-bit and 15-bit mode. And if we wanted to change things around, it's as simple as just coming here and let's go 24-bit and running the program, and it works just as well. Let's change the resolution back to 1024 by 768, and let's run it again. And we can see a bigger image now. And basically that's all there is to it here. So we initiate the image class, we initiate the reader class, and I'm using ping right here, but we could easily change this to let's change it to GIF. I'm gonna change that here, and we're gonna pull in the GIF class there, and I think I have a test image in GIF. Should be the same, I think. So if we run that, it should work. No, I do not have a test image there. Let's create one. So let's do MS Paint, and let's just create a few simple shapes. And let me just find out what folder I'm saving everything in. And we're going to change that to GIF, and we're going to change the Save tab to GIF also. All right, so let's try this again. And here we go. So the 24-bit didn't work, but let's try the 15-bit. See if that works. Yeah, that worked also. So for the when you're using the GIF format, I guess the 24-bit mode doesn't work properly. I don't know why. I'll look into it. But again, we can change this to any other formats as well. So if we wanted to use uh, BMP, which is another common format, we do the same thing. And I'll resave the image. Let's change. Let's change that here to BMP also. And let's resave the image. Or let's go, yeah, 24-bit map BMP. Let's see if that works. All right. Yeah, let's go 24-bit and see if that works. Yep, that worked perfectly. All right, so I'm going to end it here. I'll upload the code to my GitHub, and I'll put a link to it in the video description.